All right, how to tune propulsion scripts. So we've already talked about how to tune them normally, but with the new gen propulsion table, you have to understand how to tune it so that you pull off data correctly. So this has been reformatted to where the breakpoints are actually defined in the init files themselves. So to the Sunny Sky one and the Hyperion one, I've added these propulsion table options for the breakpoint, settle times, and sim time step. So in here, now the only inputs are, do you show all data and do you show data extraction? So this KM sim uses the reduced data, which is just thrust and current effectively. That's a modified current. And then show data extraction will show what I'm talking about. So what I've done is I've set up here, I typed out false true to get that option. And that will run the version that's needed for KMSim, and then I'll show you the data extraction. So let's run the Sunny Sky propulsion script to get that structure. Now that it's on the workspace, we're going to run get propulsion table false comma true. And so this pops up showing the data extraction. Effectively what's going on here is at this step, it's picking off the zero throttle is zero thrust or 0 RPM, 0 everything. That's great. Then it'll increase the throttle and pick off this RPM. So you can see that we've given the simulation propulsion sim enough time to settle out in its RPM. And then we'll take a measurement in thrust and current, or we'll thrust and current, and then everything else. And then command the new flight condition. Throttle, airspeed, and density. So since there's three things to change, throttle, airspeed, density, there's three different steps. This is throttle step, so it's a minor step. And then once we've gone through all the throttles, it'll go through an intermediate step to change either airspeed or density. I think it's airspeed. So this is a different airspeed and you get more time in order to transition. And then I'll go through all the throttles again, and then after you do all the different airspeeds, here is a major block change where you change the actual density. So this all looks really good because I've tuned it to be so. And effectively what I'm getting at here is if you see anything unusual about this, like it picks up a data point here in the curve or like right here, something weird, you can tweak those settling times. So let me show you how to do that. All you would do is go into the init propulsion script. Here's the settling times. And you have minor, intermediate, and major. And they should always be increasing. Or, these last two I have them equal. But don't decrease as you go left to right on this. So the minor again is throttle and intermediate airspeed. Last one is density. So if it was in the middle of these throttle steps, you see that current, for instance, doesn't settle out in time, which is a common problem. You can see there's a lot of oscillations in current. So I think this is good enough where it picks off current. But if you wanted to go wait even longer, you could increase the settle time on the first minor step in order to get that. Now, when you increase settling time, you increase the sim time. So the minor ones matter the most and the major matters the least in terms of increasing sim time. But I try to keep the sim running less than 5 seconds. So I also move the monitoring for how long does it take inside of get propulsion table. So I took it out of most init scripts for actual aircraft. So things are really simplified now. You just have init propulsion, then get propulsion table. And the default settings here are what we want in this context. So this is super simple. There's no set and define timers and whatnot. That all gets handled in here. And then the other nice thing is it means that you can tune these settling times per propulsion system. So I've done it for two, Hyperion and Sunny Sky, and you can see that Hyperion, we're a little bit faster on our settling times. Another thing that's different you'll notice is the time step of the sim, propulsion.dt. So in Git propulsion table, it looks right here for sim settings. If propulsion.dt is defined, it uses that for the sim. Otherwise, it defaults to 100 hertz. So Hyperion can run at 100 hertz just fine. Sunny Sky has these oscillations, which means that you got to run it twice as fast. And even then, it only, I think, barely, is good enough for that to work. So if you see a lot of oscillations and you want to get rid of that, then I would decrease the time step. Another option, another knob you can use to tweak that is the stability factor. If you have higher rotational inertia, then you'll get less wiggles, at least in RPM. Another thing I noticed that introduces wiggles is the propulsion table itself. If your propeller file that you pull in has a lot of jaggies in it, then the sim is not going to necessarily have the easiest time figuring out what the settling condition is. So you'll need to smooth that out a little bit. So for instance, we'll look at Sunny Sky here. If I set a breakpoint real quick and we run this guy, we just prop table, figure, plot. You can see there's these peaks and valleys all the way through here. And I don't think that's realistic, so I went ahead and smoothed it out. So I just used the smoothing function, which is a 5-point moving average by default. And so if we instead use the left part of that, which is after smoothing, you can see what I'm talking about. And I feel like we haven't really lost any information by doing that. It still has the correct trend. It's not like we smoothed all the data out of it. We just don't have as sharp of peaks and valleys, except for the overall trend. That we want is there's some kind of peak up here, and then it goes down. So that's something else you could look for. I changed the power gain and thrust gain implementations. So I think power should always be just number of blades divided by 2. For thrust, I made sure that at a minimum you use thrust gain of 1. That is, you don't apply this 0.9 factor to it if you're on a 2-blade prop, because that's what the tables actually are for. So there's no losses in thrust because blades are closer together and in each other's wakes and whatnot. And I think that mostly covers it. I know that's a lot, but the point is, what you need to do is during development, run it with these settings, false true. And that'll pop up this pretty picture where you can make sure that it's doing what you expect it to be doing. That you're picking off thrust and current at good times and that it's had enough time to settle out. And if you need to fix that, then they're now, your options are all in the propulsion init file. So use Sunny Sky and use Hyperion as examples of how to do this if you need to do this in the future. And if you have new aircraft scripts, they might need to be modified slightly so that it doesn't repeat this display, starting propulsion performance analysis and then timing it and stuff. So I think that's it. Just direct message me if you have any questions. Thank you.